Hello guys, this is Math Minders Academy. If you are joining us for the first time and you are yet to subscribe to our channel, we urge you to hit the subscription button, press on the notification bell so that each time we release a new video, you'll be among the first to receive it. Share this video, like it, go to the comment section and tell us what you feel about this video. So today, guys, we are going to look at the demonstration of a very important theorem in circle geometry. What I have here on the screen is a Geogebra app. Geogebra is an open source app which we can use to demonstrate a lot of things in mathematics. We can animate objects and make learning in mathematics much more interactive. So today we are going to look at the theorem in circle geometry that says the sum of the opposite angles of a cyclic quadrilateral is supplementary. That is, when you add up the opposite angles of a cyclic quadrilateral, you will get 180 degrees. So I'm going to use this application to demonstrate it. So the first thing I'm going to do here is to draw a circle. So I'm going to define the radius of this circle. So I'll go ahead on the input box. I'm going to type R equals 5 because I want that to be the radius of the circle. And then I want my circle to have a center. So I'm going to define the center as O, and I'm going to give the center of this circle as 0, 0. So that's the center. So I'll go on now to use the command, to bring up the circle. Of course, if you are interested in learning GeoGebra, you can drop a comment on the comment section. Let me know, inbox me if you want to learn GeoGebra. I will not hesitate to put you through. So let's proceed. So now I'm going to define my circle. Use a circle command. All right. And I have my point, which is the radius, and that's point O. I mean the center of the circle, point O, and I have my radius as R. Okay, so I have my circle. All right. Now I'm going to, I want 4 points on the circumference of this circle because I'm going to build a quadrilateral, a cyclic quadrilateral. That is, a quadrilateral, of course, we know a quadrilateral to be a four-sided geometrical shape, but it becomes cyclic when the circumference of the circle goes round about the vertices of this quadrilateral. So I want to build the quadrilateral on this circle to make it cyclic. So I need 4 points because the 4 vertices of the cyclic of the quadrilateral need to touch the circumference of the circle. So, but I need to develop a slider. Of course, yeah, if this is your first time seeing GeoGebra, it may be confusing, but of course, the principle I want to demonstrate will become very much clear after I am done building the quadrilateral. So I'm going to define slider. Okay, I'll go to the slider tool, and I need the slider to be my angle. So I'm going to take T1 to be my first slider. Of course, you can see the minimum value is 0 degree. My maximum is 260 degrees because you're going to go, round about the circle, and I want the increment to be 1 degree. So I take this T1, I move again to get the second slider, T2. All right, the same parameter. I get the third slider, still the angle, call it T3. All right. And I take the fourth slider. I'm going to call it T4, okay? Good. Now, so let me now define all the vertices of the quadrilateral. So I take the first vectors, which is, I want a point that will define the first vectors, and I'm going to write it in terms of the, the slider. So I have, I'm going to take R times, I'll use the parametric equation for circle. So I'm going to use R times cos, let's say cos T1, okay, comma. So I take R times sine, open bracket, T1. Okay. So let's see what we have there. Let's close this T1 here. It's not closed. Okay. Okay. So we have how many brackets open? 1, 2, 3. So we close this. Okay. So let's see if we get this point A. Okay. Okay. So we can use, let's define this cosine. Yeah, let's use this cos here. Good. And let's define this sine using the function. Okay, let's use this. Okay. Okay, the brackets are not balanced. Let's check it. We have how many brackets open? 1. Okay, we open this. Okay. Okay, I think the brackets are balanced now. Beautiful. So I have point A, right? An independent point can move. You can see that. Let me increase this point. Let me increase this point. Beautiful. Okay, so maybe I'll give it a color. Beautiful. So we have this point A moving. Now let's define point B. Let's define point B using also the parametric equation of a circle that gives us, we have R multiplied by, we take cos T2, close the bracket, we take R again, multiply by sine T2. Okay. So we have point B. Oh, beautiful. So let's take point C. Point C will give us, let's open a bracket, and we have R multiplied by, we take cos T3. Okay. Comma, we take R, we multiply by sine T3. Okay, that defines the third one. So let's shift it. Oh, beautiful. Beautiful. So let's make it colorful. So we can see that point. So that point is out. So the last point, point D, will give us, let's take R times cos T4. Okay. Take R times sine. Let's also take T4. Okay, beautiful. So we have the fourth one. Okay, all the points are seen here. Now, let's look at getting our quadrilateral. So we are going to use a command. We'll go to the input bar and type poly to get our polygon command. And that is going to give us, it will take the polygon command that said point, 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 And so we put the first point A, the second point B, third point C, and our fourth point is D. Okay, beautiful. So we are going to adjust our quadrilateral. So we have A, we have, okay, we can have this, beautiful. Okay, good, guys. You can see the cyclic quadrilateral. The cyclic quadrilateral. Now, what we want to demonstrate here is the fact that the opposite, the sum of the opposite angles of a cyclic quadrilateral add up to 180 degrees. That's what the theorem is all about. And we want to establish this. So let's pick two opposite angles. Let's pick angle A and angle C. Angle A and angle C. So let's go to the toolbar and pick, okay, this is angle. So we select angle. So we are going to move anti-clockwise if we need to get the interior angle of this cyclic quadrilateral. So let's take, I want angle A, so I'm going to move BAD. BAD, let's see the size of the angle there. Let's see the size of the angle. Guys, can you see it? 111 degrees. 111 degrees. Let me see if I can increase the font so that you can see that clearly. 111 degrees, guys. Now, I want to see angle DCB. We are moving in a clockwise direction. Angle DCB. Wow, guys. We have 69 degrees. If you add up 111 degrees and 69 degrees, it gives you 180 degrees, guys. That is the theorem. The theorem says the sum of the opposite angles of a cyclic quadrilateral is supplementary. That is, it adds up to 180 degrees. Let's pick another two opposite angles of a cyclic quadrilateral. Let's pick angle B and angle D, and let us find the individual angles and see whether it will sum up to 180 degrees. Guys, let's pick angle CBA, 93, 93, 93. That means the other angle need to give us 87. Let's check. Let's see. We angle ADC give us 87. Angle ADC. Wow. Wow. Look at that. Look at that. 87 degrees. And guys, when you add 93 degrees and 87 degrees, it gives you 180 degrees. So we have seen the validity of this theorem if you look at it in the light of Geogebra. Guys, pay attention to all our video releases. We are going to be establishing more and more geometrical theorems that deal with circle, that involve tangent, or the circle theorems. We are going to demonstrate them using Geogebra. So, did you find any value in today's tutorial? If you do, and you are yet to subscribe to our channel, we urge you to subscribe right now, hit the notification bell so that each time we release a new video, you'll be among the first to receive it. Tell us what you feel about this video in the comment section. Share this video. Guys, like this video. We urge you to be with us in our next tutorial class where we'll be establishing yet another beautiful circle geometry theorems. See you in our next class. This is Math Minders Academy, saying goodbye for now.
In the midnight glow where the stars align, we lose ourselves in the rhythm divine. Underneath the sky painted with dreams, we're chasing the echoes of silent screams. Caught